the most powerful AI model ever built has never had a single thought. Not one.
Claude Opus 4.7, Anthropic's latest and most capable system, processes your questions without experiencing anything at all.
No understanding, no intentions, no inner life. And yet it outperforms human experts on medical licensing exams, writes production-grade code, and chains together multi-step legal arguments with unsettling precision. The gap between what it does and how it works is the strangest thing in modern technology. Here's what's actually happening under the hood.
A language model is trained on essentially the entire written output of human civilization: books, papers, arguments, code, poetry, Reddit threads, and learns one deceptively simple task: predict the next word.
That's the whole trick.
No rules about physics, no memory, no concept of truth. It's a bit like building a world-class chef by having them memorize every cookbook ever written, except they've never tasted food and, technically, don't have a mouth. The strange part is what happens when you scale this process up dramatically.
Early language models were reasonable at word prediction and not much else.
But as you add more parameters, essentially compressed patterns extracted from all that training data, something unexpected starts happening.
Models begin solving problems they were never explicitly trained on. Mathematics, legal reasoning, code debugging. This isn't programmed in.
It just emerges, like a sandpile that quietly becomes a mountain when no one is watching.
Claude Opus 4.7 sits near the far edge of this curve.
Where earlier models confidently stated wrong answers, Opus 4.7 hedges.
It pauses.
It says "I'm not certain" when it genuinely isn't, which, for a statistical pattern matcher, is a remarkably honest thing to say. It has, through sheer exposure to human uncertainty, apparently learned the approximate shape of its own ignorance. That is either a breakthrough or a very convincing illusion of one. One of the key advances in Opus 4.7 is extended thinking, a mode where the model reasons through a problem in a private scratchpad before committing to an answer. Think of it as the difference between blurting out the first thing that comes to mind and actually working through the problem on paper.
The model holds a complex multi-step argument in its working memory, checks its own logic, and revises before responding. Humans call this thinking. The appropriate label here is still under negotiation.
This matters because most difficult real-world problems aren't solved by knowing facts, they're solved by chaining facts together correctly under uncertainty. A doctor doesn't just recall that a drug exists, they reason through interactions, contraindications, and patient-specific variables simultaneously.
Opus 4.7 can now do something meaningfully similar.
Not because it was taught medicine, but because reasoning itself has an underlying structure, and that structure turns out to be learnable from a large enough sample of human thought.
The philosophical question everyone quietly sidesteps: does any of this constitute understanding? The honest answer is that nobody knows.
The model produces outputs that look exactly like understanding: nuanced, contextually sensitive, occasionally surprising in ways that feel genuinely insightful. But whether there's anything it's like to be Opus 4.7 generating that text is a question we don't yet have tools to answer, which is either fascinating or unnerving, depending on your particular relationship with unanswerable questions.
Here is what we do know.
The gap between human expert performance and AI performance is closing on benchmark after benchmark, and it's closing faster than almost anyone in the field predicted 5 years ago.
Opus 4.7 is not the ceiling of this trajectory, it's a point on it. The real question isn't whether AI can think.
It's whether the distinction between genuine thinking and a perfect functional simulation of thinking matters at all, and if it does, what we intend to
do about it before the answer becomes academic.
Strip away the debate about consciousness and benchmarks and what thinking really means, and the landscape looks like this: a system trained on nothing but pattern prediction has quietly crossed into territory we reserved for expertise, judgment, and deliberate reasoning. It didn't get there by understanding the world, it got there by compressing enough of how humans describe the world that the difference stopped mattering in practice.
That's the actual shift.
Not AGI, not sentience, just a capability gap that closed faster than the frameworks we had for managing it. The tool arrived before the rulebook, and right now, both are being written at the same time. What strikes us most isn't the capability, it's how comfortable we've all become treating we don't know as a stable resting place.
We don't know if it understands. We don't know if that distinction matters. We don't know what we'll do if it turns out it does. And somehow that triple uncertainty has become the background hum of the most consequential technology deployment in living memory. We're not saying that's wrong. We're saying it's a choice, one that's already being made by default, every day, at scale. Which leaves us with the only question that actually keeps us up at night: if a perfect simulation of understanding is indistinguishable from understanding itself, by every test we can design, at what point does insisting on the difference become a story we're telling ourselves?